Okay, good evening. Thank you for coming and thank you for joining online. Today with my good friend Etienne, we're going to talk about artificial intelligence and the two things that we hope you'll get out of this presentation tonight. Number one, that AI is no magic. There's no magic into everything you're going to see, and this is very important to me and to Etienne to kind of break the myth and to explain how this thing works. And the second thing is we hope you'll get a very general understanding of one particular type of artificial intelligence, the one that is called the image generation, or the overarching technology is called AIGC, Artificial Intelligence Generated Content. And today we decided to break down the process that is related to image generation. This will not require any technology knowledge, right? We come here as educator, Etienne even more than me. Yeah. So first of all the images that you're going to see have been, of course, obviously generated by AI, starting by this one. And every visual we used. So for some it's obvious because we use it as an illustration and we'll use it for the demonstration. But everything else has been generated by AI. Yeah. So first question, and online don't hesitate to propose an answer also in the chat. So I'll ask you to guess how many lines of code do you think is necessary to generate an image using artificial intelligence? A wild guess, you know. 10,000, 1,000, 100? Very few, you think? You don't know? No clue? Nobody wants to guess? Anybody online on the chat? No? Okay. We managed to put it down to 3 lines of code. It's a little bit small maybe for you. So on the top there, I have 3 lines of code, and this is enough to generate an image using artificial intelligence. So this demo is running on my laptop, which is not a very, very powerful laptop. So I pre-generated the image. So it took 14 minutes, almost 14 minutes to generate that image on a laptop that is not very powerful. But what is really important for this particular technology is I can download it. I can download it for free. I can use it for free. I have it on my computer. Nobody asked me to pay for anything, and I can use it. So what did I use it for? I asked the AI to generate an image of what I called a real-life Mona Lisa. So the concept of Mona Lisa exists somewhere in that model, such a big and famous painting, but I wanted a real-life Mona Lisa. And I also asked the model that this Mona Lisa would be in a kind of fashion style. So let's look at the results. This is what I got. This is the image that was generated of a real person, although that person doesn't exist and never existed. That is an evocation of Mona Lisa. So you can see it from facial expression, from the hairstyle, even from the clothing. Although the clothing is kind of modern, there's also an evocation there. So that's what we can do today with a model that is available for free on the internet. All right. So today's presentation, we're going to tell you 2 stories actually in parallel. I'm going to tell you the story of how to use this technology, where I see a business potential. And Etienne is going to tell you the story of opening up that box, looking inside the model, and understand how this is happening, and understand that it's not magic, and that is just mathematics, right? And to help you, so of course, so when I'm talking, I'm telling you this bit more of a business story, and when Etienne is talking, he's talking more about the technology story. And to make it easier, my slides are white and his slides are black. Yeah. So Etienne, how does it work? Oh, sorry, no, I'm starting. Sorry. So first of all, so again, AI-generated images. This particular tool and this particular technology is really good and really efficient to create large quantity of content. So if you're in a business that needs to create a lot of images, so for example, you have to, one a very good example I think is e-commerce, where you have to generate a lot of images, a lot of campaigns, or in marketing, then this tool is really nice because this tool is really nice at quantity and generated a large amount of quantity and generated them cheaply. And we'll get to it later. So of course, on the flip side, if you're looking for quality, this is probably not the right tool. So cheap, fast, and large quantity. So this is where we see the sweet spot, and I'm going to tell you later how we can use it and the potential we see in the business. So Etienne, how does it work?
Thank you, Stéphane. Yes, I will try to explain to you how these things work. It is important for you to understand a little, to build your own model, mental model of how those systems work, because it will allow you to use them better and to make them a little better quality result. So text to image is what you've just seen on the screen. You have a prompt, some text, and then you have a bunch of images that appear there. Now to explain this, I will have to go through 3 steps. Next. First, I will talk about just now degraded images. Then I will talk about how computers can represent ideas and concepts. And at the end, we'll bring that all together to really understand what is the essence of these systems. Next. Next. So clearly, we've seen that there is some kind of system that use a process starting from very degraded images that you cannot really see what it is, and gradually improving the image up to the final image you want to show or you want to create. So you start from a very noisy images, and then you go through a beautiful image in steps. Now, it is easy to do the opposite, to take a clean image and to gradually degrade it up to the point where you cannot read anything. That's quite understandable, easily done. But if you go to the next slide, we can see that this is also possible in the other direction. An image has enough information for us to figure out which pixels, which points in the image should not be there, which one can be taken away and replaced by, in this case, in the blue sky, you can see all those pink and black and white things can be replaced. So it is possible to clean an image if it's not too degraded. And what we do is, in a model, one of the key aspects of text-to-image systems is a model that is trained to take an image with some noise and take a little noise out of it. And those models are trained on millions and millions of images. And once they're trained, they take one image with some noise and then create another and generate a new image with a little less noise. And that model is applied several times successively, all the way to bring an image that, to our eyes, is a clean image. So this is the first element, the first aspects of those text-to-images systems. And before I continue to go under the hood, let's go back to Stéphane to talk a little more about prompts.
Yep. So I want to tell you about the good and the bad surprises that we have. Then we're trying to generate AI images. And we call it the art of the prompt. So the prompt you saw in the example that Etienne gave to you, the prompt was a picture of Barack Obama, clear sky in a garden. So let's say I want to use a prompt, and I want an image of a fireman in front of his truck. So if I put this prompt into an AI generation tool, this is the type of image that I will get. So the prompt, fireman posing beside his truck, I will get these 4 images, And with the same prompt, I'm getting different images. Now, there's a problem with these images. I don't know if some of you have noticed. Faces, right? Those faces don't really look nice. Why? One thing that you can pay attention to, if you look back at the images, the truck is very precise, right? The truck has a lot of details, and the truck has, different kind of truck, probably from different vendors or different states in the US. But the visage, the face, really not nice. Why? Because a fire truck, it's something that is clearly defined. But a fireman is not clearly defined. Actually, what they're wearing is quite clear. The uniforms is quite clear because the concept of a fireman is clear. But the face is not coming out. So how do we fix that? Well, we have to fix that by being more precise into who's this fireman. Does he have a mustache? Is he wearing glasses? And we have to give more and more and more details to fix that issue of that face being blurry. That face is blurry because the concept of the fireman is blurry. So now let's take another example. Let's say we want to advertise coffee. So I want to generate images to advertise coffee. And this time I'm going to be super precise into my target. I want an Asian, female, long hair, blah, blah, blah. So here's a prompt that is way longer. And this time I'm defining the face with a lot of features, right? So very different, very different output because I have all these keywords up there. And I'm also defining that I want a close-up. I want some solid ambient light. I want it to be Vogue magazine. So I want the picture to be a professional picture, right? Now these pictures have another issue. I don't know if you've noticed. Fingers. Too many fingers, too few fingers. Fingers have some really weird shapes, you know, because I got you to concentrate on the face and I was very precise on the face. Now the way to fix this one is different. The way to fix this one is to add what we call negative prompt. So here I've said what I want. Now I'm going to say what I don't want. So I'm going to add to the prompt that I don't want deformed fingers, I don't want extra fingers, I don't want too few fingers. So now I'm adding to the prompt the things I don't want. And now it's better. Now that has fixed my finger issue, it's not perfect yet. So if you come closer and you look at it, it's not yet perfect the way you would like it. But again, it takes 30, 40 seconds to generate 4 images. So I can generate 100 and I pick up the one I like, right? So the art of prompt. So number one, you have to be precise on the features. So you have to give a lot of details into what you want. You also need to say what you don't want, and you need to iterate until you get to images that you could use or you think would be good enough for you to use. So Etienne, you told us about getting from noise to image. What's the next step to explain the AI image generation model?
Well, you described the prompts. Now the key question is how can the computer handle these prompts? We give them text. So how can the computer use the prompt and deal with the ideas behind it? Next. Now, a prompt is more than just a sequence of letters and words that constitute the prompt itself. Each word conveys some meaning, some ideas that we humans are very good at understanding. And because we have such meaning, we can actually organize words on some kind of a map. For instance, if I take 2 directions, one which is something concrete or abstract in the horizontal direction, and in the vertical direction, I take things that are positive or negative. Then we can, if we can pick a certain number of words and we can position them. Chocolate, I like it, so I consider it's positive, and it's concrete because I can eat it. On the other hand, rubbish, I can touch it and smell it, so it's also concrete, so it's on the left, but I don't like it, it's negative word. And similarly, we have abstract words like love or hate, and we can position any kind of word in such a map. Next. Now, images also mean more than pixel. Similarly, we can position those images for what they mean in the similar type of map. And in this case, again, we have a box of chocolate, we have a party on the top middle, we have this poor kid that is lost in the supermarket as a negative concept, and so on and so on. Next. Now, what is interesting is that I want to make 2 points here. First, by placing words and images on the same map, we create a relations between words and images. if a word is positioned on a map not far from an image, the computer can assume that they are related. They mean something similar. So we can convey some sense of meaning to the particular computer. The second point I want to highlight here is, this is my map. I like chocolate. You may dislike chocolate and put it somewhere else. So you would have your own map. And on top of it, of course, there's much more than 2 ideas in the world. So those maps are much more complicated, but they are built. We all have our own map like this. Next. And actually, no, the previous one, we went to one too fast. And actually, the model will build its own map. When we train the model, looking at all those images and text, it will create its own map like this. And of course, it will create it along many more directions than abstracts and concrete. But it is its own map. And it turns out that the map that the computer has created during training makes sense to us also, to a certain point. And language models like GPT-3 and all the things that are also very popular these days, this is also what they do. They create such huge map. And if you go to the next slide, and in this here, we have an example of a representation of a vocabulary of 10,000 English words that are grouped together. And I try to highlight there in the corners in green, these words, for instance, we have an area in that map that represents English names. Another one represents music-related things like alto, orchestra, Lego, and so on. And then the 2 other clusters in that group represent technology words, some different aspects of technology. So this really shows how we can communicate with the computer with meanings, not only with humans, but the computer can take that kind of information. So this being understood, then I think I can give you back the word, Stefan, to continue on how to use those tools before we wrap up the thing at the end.
So these are new tools, and I think we need to stress on the fact that they are tools, okay? And the tool is to be used by somebody with a purpose, and they want to and achieve a goal. But the person that defines the purpose is not the tool. It's not the software, it's the person using it. So there are a lot of debates in the art community that these tools are bad and they should be banned. But the tool is not the artist. This is just a tool. And then it's a decision to use it as an artist, as a marketer, for e-commerce, for sales, for promotion. It's just a tool. But because it's a new tool, there's a new paradigm associated to it, and there is a new process that needs to be created. So I'm very interested into this and into exploring the tool and trying what works and what doesn't work, and try to define a process and try to help companies understand how they can benefit from the tool, what it's good at and what it's not good at. But because it's so complex and it's coming, as Etienne explained to us, from that very large multidimensional environment, it's actually not easy to predict what the tool is going to do. So this is a process of trials and error. So I share some of the results with you today, and we try to make it into a process. So going back to our previous example, so from the prompt there, I'm getting these 8 images. One thing that Etienne just explained that is very important. So this model is biased. This model is biased, and the way I'm using those keywords are unique to this model. And actually, this model has different versions, and I will get different results from using different words and different reasons. So you can say it's bad. It's bad to be biased. It's bad to have this association of this being positive and this being negative. You can complain about it. It doesn't change the fact that the model is biased. So if you want to use it, you have to kind of lean on these biases, and you have to go in that direction. So for example, in this one we've cleaned up a little bit. So it's kind of neutral. But there are sometimes you have to use words that seems a bit biased, but you have to use them to get to the result you want, and you have to understand what are the trigger points. So let's say I still need to figure out. I still need to push my advertising for coffee for the Asian market. towards a female audience. That is why I was going in that direction. So first, when I have this goal in mind, so I have this goal in mind to create that image. So there are a few things that I need to think about. So my goal is to create an advertising, and the advertising is there so that people will buy coffee. All right. I have a message. So my message is that this coffee is good and you should buy it. Right. There are maybe emotions that I want to have, and I want that picture to push emotions towards the person who is looking at it. I have some visual elements, and I have maybe things that are a bit more conceptual that I want to carry out. Yeah. So as we saw before, this is prompt to image. So all this I need to turn into keywords, and these keywords are the sentence that I put there. And as you saw, after that, so yeah, are these the right keywords? I don't know. Again, the model has its own internal workings. Even after using the model for a few months, there are still things that I can't figure out, and most of the things I cannot figure out. So then it's a test, and it's iteration. And I already show you a few iterations where I had to add more keywords. I had to put negative keywords. And little by little, I'm getting pictures that are looking more and more towards what I want to achieve, until I get something that I'm happy with. And that's it, and that's the winner. And then I'm going to use this image for my next campaign, for my next advertising. Yeah. So this is really this process. So the first process to kind of map out what I want to do in this dimension and maybe more dimension, make everything, I would say, flat into keywords, positive and negative. And then based on the feedback, okay, I don't want this, I add a negative keyword. I think it will look better like this. Then I'm adding some elements until I get to a picture. And I would say, I'll recognize it when it pops out. You know, let's say, oh, like that. Okay, that's the one. I'm going to use this one, right? So again, if we want to continue, and somehow we're also going to generate more and more images until we get to the one that is okay. This one is good. For me, it's actually the top left, but maybe for you, it's a different one if it's your own brand of coffee. But as you see, continually adding and replacing keywords, adding, removing. So I added a smile. Okay, first time I added the smile, the teeth were not always white. So now, okay, no, I want white teeth. So I have to give it this instruction. And then again, adding and removing until I get to something that is really nice. So if we want to compare AI generation and traditional techniques, what are the differences? Right. So first of all, these tools, the AI generation tools, they are very versatile. So in this example, I've generated photorealistic images, but they also can generate cartoons. They can generate oil painting, canvas. They can generate different style of paintings. They can generate different elements. With traditional technique, if I want an oil painting, I need a canvas, I need the oil, and I need a brush, and I need to have it. If I want to take pictures, I need the model, I need a set, and I need a camera. If I want to do black and white drawing, I need a pencil and I need a paper. But the AI tools, at least the one we're using, have been trained with a lot of different styles, and I can switch the style with the same tool, and getting to the result that I want. So this is definitely a plus on the side of the AI generation. So infinite generation. I'm not going to run out of paper. I'm not going to run out of ink. I can generate. So it's a matter of time, a bit of processing power, but I can generate and generate and generate. And I can generate at constant cost. So if I want to take a picture with 1,000 people in the background, white elephant, and an airplane taking off, I need to set that up. But with AI generation tool, it's a different prompt. I put all those elements in the prompt, and it costs me the same thing as generating a bowl of milk with a cat. You know, the cost is constant. There's no cost into more details, into more elements. Of course, if you want to do this in real life, you need all those props, all those actors, and everybody. Of course, the cost will be very, very variable. If you want to go and shoot in the Bahamas, you have to fly your crew there. In the prompt, you put Bahamas, and that's it. Everything happens in the Bahamas, again, at a completely constant cost. So the next one is there's a big debate on the copyright. So the pictures that have been generated, they are supposedly copyright free because they don't infringe on any material. There's a big debate because the model has been trained with copyrighted images. So if I take the model and I say, okay, I want a picture of Tom Cruise riding a bicycle, it's going to give me a picture of Tom Cruise riding a bicycle. It doesn't mean I have the right to use Tom Cruise image. But because they are in the model, and I think they are trying to clean up the model, so actually this is not possible anymore. So they don't have those copyright issues. But all the models that don't exist, all these Asian female models have been generated by the model. I don't need to pay anybody. They don't exist. Nobody. Maybe somebody looks like one of them. Maybe, not even sure. But that's not a picture of that person. So this is why there is this idea that there is no copyright in there. As far as I know, there's no legal frame yet. The tool is brand new. There are probably going to be some lawsuits that are coming that are hopefully clarify the things, not too fast. Yeah. But that's happening. So these are things that are positive aspect of the AI generation tool. Again, if you want to generate cheaply large quantity of image at a constant cost, and you want to generate a lot of them, and you are willing to spend the time to go through the creative process of selecting the one, adjusting and going through that process. One thing that is a bit tricky with the AI generation tool, if you want twice the picture of the same person, it's not that straightforward. So there's a way to do that. But if I have a model here and I want to take 5 pictures of that person, you will immediately see those are 5 pictures of the same person. By default, the AI generation tools, if I call it 5 times, it's going to give me 5 different persons. Yeah. So there is a way that I can take that person's picture, put it back into the model, and I can do it. But it takes an extra effort to have the same person in different settings, different pictures. So if you're thinking about using those tools to tell a story, comic book, or even generate a movie, there's an extra effort to make sure you have the same character in every scene. Because by default, you get somebody different every time. Yeah. And then unpredictable results. So as you saw from the first trial, and even the latest one, not every output, not every picture is good. Not every picture has the right level of quality. Even the negative prompt, the negative keywords where I say I don't want deformed fingers, sometimes the fingers look odd. The teeth also sometimes look odd. The eyes sometimes will have a problem as well. So the output is not always the one you want. Again, we're looking at quantity or the quality using these tools. But there are tons of use cases for that. Yeah. So Etienne, can you now bring back together the concept from denoising an image using the keywords? So how does it work, and how does it make those models work together?
Yes, now we can reveal the truth. Next slide. So we've seen that text-to-images system use a trained model to improve images step by step by applying this denoising model to the image successively. In the early days, it would take the previous one. In the early days, it would take something like 1,000 steps. Early days is about 2 years ago. Right? And nowadays, you can get away with 30 to 70 steps. In this case, I took 50 steps. So the first image is a random image, and then the second one is 10 steps later, then 20, 30, all the way to 50. So we can see clearly that trained model is cleaning up the image step by step. But the question now is, okay, we saw that the prompt is very important. And where does the prompt come into this? So let's see what happens if we don't have a prompt. The same model starts from the same image, random image, a lot of noise, and it ends up with some random image, which is cleaner. So next, it is a reasonable image. You can see you have some kind of alley, you have a river at the bottom, some public lights. It could be a simple image or a composite of 2 images. It is something that is not a totally random image. but it's nothing to do with whatever we want. It's a totally random image. So let's look in a little more how that works. So next slide. Let's come back to that map from the computer. This is the map the computer has built where it can position images and text. And in yellow there, we have our initial random image. This is basically, that map represents all possible images, whether they are clean, beautiful, ugly, noisy, and all words and sentences that we can imagine. It's all on that map somewhere. By picking a random place on that map, okay, we have one image. Now, next, when we use the denoiser is roaming all the whole space and cleans up the image step by step to get something that is a little more pleasing to our eyes, but in this huge space. So basically, by not giving a prompt, the model doesn't know where to go. And the space is so big that it creates any kind of random images. So what the prompt is doing is guiding. So next. So we have the same map, the same initial image, but now we give it a prompt. What the prompt is doing is defining one area in that map that represents what is said in the prompt. Obama in a park, happy face, or I forgot exactly what was in the prompt. That basically is in that area. Next. That means that this random image from before, it is banned. It cannot be. It's out of the place we define by the prompt. So it will not go there. And when we apply our model that will clean up the image, then now the model knows where to go. It knows to go in that area of Obamas in parks with a happy face. And it could generate different images that represent the same ideas, but it will represent one of image that represent that idea. And this is exactly what the prompt is doing. And this is how those models are working. Next. So in the next slide, you have a summary of what it is doing. We start from random noise on the left. And if we do not have a prompt, the first module would clean up an image and create something that is an image that is more pleasing to our eyes than the initial one, but doesn't mean much. But by giving it a prompt and guiding in that area of the computer's map, which the prompt defines, so here facing the camera, in the park, soft colors, and so on, then we restrict the denoising model to stick to images that represent what we want. And this is, as Stefan said, this is one of the reasons why we do need to try different ways. We need to define the right spot on that map, and that map, we don't know it. It's the computer's map. We have to guess it. And the only way we have to guess is by trying different words, different prompts, like a kid that is learning a language without the rules, just by listening, and then they're seeing the reaction of people reacting to when he's speaking or she's speaking. So it's clearly the prompt is an experiment we have to do to define that small zone in the computer's representation of images and words, and then that will generate that image.
Thank you, Etienne, for this explanation. So from this example of AI generation of images, this is not the only one. So we choose this one to illustrate tonight, but this is not the only model, and this is not the only innovation that happened in artificial intelligence in the past few years. So actually, if we look at the other types of models, they all pass a critical point that is extremely useful and important for business application. So the model that Etienne has described and the model that we use to generate all those images, including this one, have been trained with, I think, billions, several billions of images. So use a very, very big data set. And what is important is that we can transfer that learning. So in the past, when you wanted to create your own artificial intelligence model or machine learning, you had to get your own data, and then you had to get all this data and you had to train your model. Now, what we call pre-trained model is that somebody has done all the training, and then you can use it directly. So this is one very important step, because of course, it's going to save time if you want to use that model. But that model, you can continue to train it. So let's say, for example, so these are generic models. As you see, we can generate a lot of things. But for example, if you're a product company and you want your products to be represented in this image because you want to do marketing campaign, then you'll have to get your own images on top of it. But you only need maybe 1,000 or a couple of thousand images just to show the model, by the way, this is my product. And I want my product in every single of my pictures. But then you don't need to tell the model, this is a cat, this is a car, this is a car, this is an airplane. All these very general concepts are already there from that billion images. And as you saw from the beginning, from the demo, I can run it from my laptop. It's a bit slow, but you have access to it. It's completely free so far. They're probably still figuring out the business model, but you can use it. So for a company today can take that model, use it as a very generic experiment as we use today, but you can also, with a little bit more knowledge and a bit more understanding of the technology, you can even make it your own model and get it to go into things that are more precise and that really fits your own purpose, and get you to create your own advertising. Again, just one example. The good thing also is that because this model belongs at the end belongs to you and it's your own, you don't need to share your data. So a lot of the AI business has been running for the last 10, 15 years by AI companies. And these AI companies, they ask you for your data and then they give you a result in exchange. And they don't only ask you for your data, they ask your competitors also for their data, because they need 1 billion pieces of data points to train their own model. Now with these new pre-trained models, you don't need that. You don't need to give your data out, and you don't need to get in bed with an AI vendor. You can run your own model, And I know that Etienne is also a big proponent of training companies and getting people, and this is also part of what we're doing tonight to get you all to better understand AI, to give you hopefully the idea to go and train it, but then tomorrow, day after tomorrow, you can run it in your own company and you can train your own model. So it's not only for text to image. So what we show you today is text to image, but it's only one of the model. You can have image to text. That's image recognition. Facial recognition, but that can be. There are a lot of more declination of that. You can have voice to text. So now voice recognition is quite good. And again, in one language, you can have a pre-trained model. That is a very generic model that can recognize Chinese or can recognize Dutch or German. And then you can add a specific vocabulary to your own business, to your own semantic, and then you can use it so that you get automatic recognition of people who are calling your call center, for example. It can be image to image. So the model that we use for text to image also can be image to image, or image plus text to image. So you can take an existing image and ask the model to change it, to change things into it. So and they are way much more than that, So these models, you can train them. You can have a core process that exists inside your own company. And then on the other side, sorry, it's a bit hidden. You can go the other way around. So you can go back to text to voice, for example. You can have voice generation, or you can generate an image from the text, or it can be text to text. That is a famous ChatGPT. So for example, if you want to have a booking service, you need to recognize the voice, change it to text. Let's say it's a restaurant, so you have your central process is your booking table booking system. And then if the table is available, you go from text to voice and you reply, and that works. I've heard it actually from a Chinese restaurant chain that is called Haidilao. They actually have AI booking, and the AI will have a very limited semantic conversation, and it works really well. But it sounds a bit weird at the end. Like something is wrong with the conversation, but it's a conversation, and it repeats your order. And it tells you, okay, book a table in this restaurant for 10 people at this time. Yes, yes. And then you can interrupt it and say, so, and this is how these models can be very easily built. And that was already a few years ago, so it probably cost them a lot of money. They probably need to have a lot of data. I think today the same thing can be built way cheaper and way easier because we have all these models that are coming out, that are available, and more companies are sharing their model. So now that this is really a true democratization of AI. So I hope that was interesting. I hope you get a better understanding of one of those models of the text to image. I think now we can open the floor for Q&A. Okay, conclusion, I think I already done it, yeah. So are there any questions? Online, offline? Everything was crystal clear? You're asking for the program. So the program we use, we used something that is called Stable Diffusion. So it's the name of the package that can be downloaded from the internet. There's also a web version. So we'll send out the presentation, and I think we put the link there. So I use it and I download it on my laptop, and I wrote those few lines of code. But there's also a website where you can put the text, you can play with it. Just make sure you don't have anything important to do afterwards, because you're going to spend hours playing with it. The first time you look at it, with the few tips that I gave to you, you're going to spend at least an hour on it. But it's getting actually. I mean, they put resources there, computation resources there for free. Recently, it's not available all the time. There's such a heavy traffic. So many people want to test it that sometimes there are too many users and it doesn't reply. You know. But if you're lucky and not too many people are looking at it, or maybe early in the morning in the US, you can probably use it. So it's called Stable Diffusion. You know. But we'll send you the PPT, and you'll have the URL there that you can play by yourself.
We had a question online. I think it's at the beginning of the presentation. You were mentioning that you needed to specify, for example, the number of fingers that you needed. Why don't you need to precise as well? How many? The number of ears, for example, or eyes, or anything?
I think so. So it's a good question. So. Our view of a human person, we have a lot of very implicit things that we take for granted. So five fingers, okay, more or less, on average, all right? 2 eyes, 2 ears, and if you have to draw somebody, and even small kids, they will put those elements together, right? They will say, okay, this is the face, these are the ears, and they're actually counting, and you're actually putting these elements. But this is not the way it works. So Etienne showed us that it doesn't work like this. It's not drawing an oval and putting 2 eyes and putting a nose and putting ears. It's getting from that fuzzy image, and the features start to appear. And the features are starting to appear, and they appear by, I would say, imitation. By going through that space, they go there. So having a face, having 2 eyes and 2 ears and a nose, if you don't have these features, and these features were not clear in the first example with the fireman. If you recall, they were kind of blurry. They were there, but they were not precise enough. You know. But having 6 fingers, if you take a step back and you don't look closely, actually it looks the same, and it feels the same. And for the algorithm, 4, 5, or 6 fingers, it doesn't make a lot of difference. So if you understand the idea of space and those pictures being in that space, these two a picture with 5 fingers, 3 fingers, or 6 fingers, they're actually very close together in that space. It's not a very big difference in terms of representation. But for us humans, we look at it and we fixate on it, and we're like, something is wrong, because the way we analyze that picture and the way we break it down is completely different from the way the algorithm is working. You know, because the algorithm is not painting the features one by one. It's more of sculpturing. It's more of a sculpture process where it refines and things are appearing. It's not painting fingers one by one. You know. I hope I answered that question clearly. Anything to add on that, Etienne? Or
I know you said it very well.
Thank you. You're too kind. More questions?
we can transfer the text into feelings. Can you give an example?
Text to feelings. So there are models that are So feelings, emotion. Do you have experience with that, Etienne?
Yes. For instance, if we take the Obama example there, I made a bunch where you have a happy face, you have angry, sad, and every time you change one word in the prompt, you can see the face changing. And the way these things work is because when the model was trained, it was exposed to images of different styles, and then the word sad was associated with this type of image, and the word happy with this type of image, and so on. And then in that big map, what we normally mention that representation, that's the smart name, but it's basically a map. And the same way as we say 5 fingers or 4 fingers, if we say sad or happy, it represents different characteristics of images, which then can be expressed in the image. But it's quite amazing if you experiment on the web or on your computer, and you take a person, and you don't change anything else in the prompt. You just have happy face, sad face, angry face. You can immediately see the face changing.
Your question was from text to sentiment, right? Yeah. So this one is sentiment to picture. Yeah. So text to sentiment. So they are
sentiment classification.
Sentiment analysis, an LNP model.
Okay. Sentiment classification. Yeah, right. This is actually one. This is done very easily now. Similar, what we would use for that to start with is a language model, and the language model represents the words that mean different sentiments in different ways, but then you do need to have some examples of text that you consider are one sentiment, a text that you consider being another sentiment, and then you can fine-tune a model using a pre-trained language model. Then you do a short training, the same way as we mentioned with 1,000 images there, that you would have 500 or 1,000 or a few more sentences that represent each sentiment. And then you can classify it. And then you give it new text, and it will say probability that it is angry is high, and that it's neutral is low. And this is widely used in customer services these days to figure out who you need to handle quickly and who you can make wait a little longer.
So again, as I explained before, if you have let's say 1,000 product review, it would be enough to specialize a model that's already been trained.
Yes.
I think there's a fast AI model in sentiment analysis, right? There's one, right? Right, Nicolas? Yeah.
So you do.
I think there is, right. So you can take a model that's already there and specialize it with only 1,000 pieces of data, or maybe 2,000. But you still need to classify your own data to make it more accurate into your own space and your own semantic. But you don't need to go and train in the full language. If it's Chinese product review or English product review, you don't start from zero. You don't start from a blank brain from a baby, and you need to teach it everything. You already have a model that is 95% trained, and now the training can be pretty fast and efficient. This is the true revolution of the last couple of years on AI, on transfer of training in AI models. So quite quick now. Yeah. And again, I think the idea would be to go and try and get somebody to help you maybe, and play with the model and try and experiment and see how easy it is or how difficult it is. Is it an easy problem or hard problem? This is one of the issues in artificial intelligence. It's quite difficult to know at the beginning, is this a hard problem or is this an easy problem? But because now the cost of experiment has been going down so radically, testing the hypothesis can be done in a couple of days, right? So then it's not a huge project, and if it works immediately, then great. If it doesn't work, okay, do you want to spend more or less? But chances are, in a few days, you already can figure out what's going to work, what's not going to work. And again, you don't depend on the AI vendor crawling the whole Tmall for all the product reviews and getting all the data and crunching billions of data points. That's it. We've answered all the questions, or yeah, okay.
So you've mentioned about refining a model to be more specialized to a special need, to a business need, for instance. So how do you see the business model to evolve? We currently have few tech providers like OpenAI and Stable Diffusion. Do you think that it will be, these providers will have like a Google kind of ownership of certain technology, and they will sell it with API to companies which will try to specialize it, or will have a more diversity, more diverse environment around these techs? How do you think it will evolve around that?
It's difficult to predict what would be the business model. So today we have both. So today we have both on the market. So we have the OpenAI that are more on the SaaS business, and their models are behind closed door, and you have to call them, and they give you like you can call it 100 times or 1,000 times per day, and after that you need to pay. And this is their business model, and this is how they work. And then on the other side, you have the fast AI, Hugging Face, where a lot of models are being shared by companies. Where the models are available, you can download them and you can do whatever you want for free. I think the second one, it's not because it's free, but it's more interesting because it sparks more innovation, because more people can play with them and more people can understand how it works, and more people can say, okay, I took that model and these two models and I made something new. And I think the creativity on that space is going to be faster and faster. How are we going to pay? How are these people getting paid? I see it personally. I see it the same way as the open source movement has been going on for now 30 years or 40 years, right? We still have an operating system that is called Linux, that has a foundation that you still can download for free, you still can install for free, and everybody can use for free. And it's very stable and it's running fine. You still have free version of MySQL, of databases. So we have a lot of things that are for free, where people do it for their own benefits. They're professionals. They want to be part of that movement, and they want to give things for free, and because they build on each other's job. So I hope that this whole movement is going to continue. And at the end, companies have to use them. You know, companies have to use them, and they have to use them in a way that they can make money with. You know, so I think the two models are going to coexist. The open source model has been getting a lot of traction. I mean, even big companies are going there into a freemium model, like you can get this for free, and if you pay, you have this type of additional services. So I hope this is going to continue in the future, because this is the way we can continue and refine the model, and then the innovation will be faster, definitely in that direction. You know, but I can't. It's just my prediction. What is your prediction, Etienne?
Yeah, I think also if you look at companies like OpenAI and those big guys, they have to cover things that are so general because and then therefore they have to put so much money to create that. So they are in some kind of a niche like the Google in internet. But you have a lot of the scale, you have a very long tail of applications of a lot of different types of application for AI systems that are unique for one industry or even for one company. And this is where the open source track is booming, because you don't see them, but you have thousands of initiatives that are operational today at different levels in HR, in finance, in marketing, but also in medical application and so on. And those are too small for the big guys to invest and show their power, but they're there. And these are the areas where any company, any organization, whether it's private or not private, can enter thanks to those tools that are open source and grab it and then fine tune it for yourself, and then either keep it for you because you're allowed to keep it for you, or reopen it to other people to do further work with it. So I do believe that at least for the, let's say 10 years, which is deep science fiction for, for AI, that trend will continue. Now, there will be a few things For instance, if you're in a big corporate and you need a certain level of environment, okay, you may be stuck with Azure and Microsoft because you need to use the rest of the infrastructure, these kind of things. These are other considerations. So the big guys, of course, will have a position, but you have a lot of space for innovation and creating things that are used for your purpose only, no one else's, and that no one else, which are harder for other people to copy because you solve your own problem, not someone else's problem. But you do it using those wonderful tools of AI.
And I think to add to what Etienne said, I think what is already very important is to know that it's possible. And even the model that have been developed by OpenAI that are behind closed doors, they're still quite open about how they did it. So if you have the time and the computation power and you want to do it by yourself, you still can do it because they are pushing. So all the AI industry and all those companies, they are pushing the frontier almost every day, every week, coming out with a new model, finding that this works better than that. And the fact that all these people are working on all these models and experimenting the way I do at my level and say, okay, this is how you can use the model, this is can use that. It's all part of the same ecosystem of showing that it's possible, what can we do, and how far we can go, and then bring it like one centimeter further, 1 centimeter further, 1 centimeter further. Yeah. So I'm also quite hopeful about the fact that even if somebody is trying to lock down the model behind closed doors, it's not so difficult to recreate it anymore. One thing very specific about AI, I think, is there's no proprietary algorithm. All the AI algorithms are all results of public research. So if somebody has time and they want to do it, and a lot of people have time and decide to that, and people who are doing research, most of them, they publish their code, they publish their things because they're not interested. I mean, their currency is not so much the money once they have that grant, then the ability to publish. But in order to publish, they need to develop, and then once it's there and it's working fine, and they put it there and it's available. So I think it's still going to be there, and it's still going to continue. I actually hope so. Yeah. Other questions? Online? No? Was there another one?
No.
So AI is impressionist. Okay, yeah, it's a sort of. That's a good summary.
Yes.
All right. We want to leave you with one final thought before we close. We want to imagine that you could spend 1 week sitting side by side with an AI programmer. And we want you to imagine the type of project you would like to work on. So it can be professional, it can be personal, it can be one of your passion, it can be something related to non-profits, related to an organization you belong to. But I hope we've given you enough of those keys and enough understanding to go and imagine and say, okay, if you have that 1 week, what project you will work on. You don't need to say it out loud, but let you to think about that, and hopefully that deeper understanding that we shared with you today will make it easier for you to figure this out. Yeah. So thank you, Alex. Thank you, the team at the Chamber of Commerce.
Thanks, Stéphane, for sharing your insights. Thanks as well for Etienne, who is online, and thanks everyone for joining us tonight. And we share the replay link to everyone. And for the people offline, we can go and further discuss around the drink.